come back to another daily questions set matrix zeros. So given an n by n integer matrix, and if an element is 0, we want to set the entire row and column to zeros, and you must do it in place. So that means you cannot create a new data structure. So, okay, yeah, it's just saying that you don't do another data structure. Basically, we don't want to create a new array and then copy things over. It's interesting because in the follow-up it says straightforward solution using all of n space is probably a bad idea. A simple improvement using all of m plus n space, but still not the best solution. So let's look at the all of n plus n space solution first, and then we'll move on and see that how can we do it in constant space. Right, so a simple idea that you will see is that whenever you see a 0, you create a set, like a column set and a row set, so that the row set keep at most m rows that can possibly be have a 0 in that, and then the columns keep the n, so it'll be all of n plus n. So yeah, it's maybe not too hard to understand, but let's just work on it. So basically we have rows 0, 1, 2, and then a column 0 and 2. So we go through every of the element. Just take a time to be of m by n. So we need to go through every element and see which one is 0, right? As soon as we find a 0, we have a row set. So we'll add this to be row 1 and then column 1, right? So this is the set, right? The set of rows can keep at most m element, and then the set of column can keep at most n elements. So by that being said, that our space will be of n plus n. And how this works is that later on we'll go through every row that has a 0. In this case, it's 1, and then we want to zero out entire row, so make this all 0. And then we go through all the columns that have 0 as well, and then we zero out everything. So the resulting array will be one over here, one over here, and then the entire row and columns that have 0 will be 0 out. So the same here. So we will find that the rows that have 0, it's the first one. So and 0 out is the first row, and then for our first column and the last column will 0 out the columns as well because it has 0. So I'm not sure if I have to write this down, but quickly go through the code. So you initialize a set for rows and columns, and then for simplicity you do initialize the m and n for the number of rows and columns. So we go through each of the element, each of the block in the matrix. So if the matrix at ij is equals to 0, we add them into their corresponding set. And then we go through all the rows in rows that, so this means it's like which row has like the 0, right? So in this case, since we already have a fixed row, so we go through every column, and then for that matrix at row and then j we'll set to 0, and then we do the same for columns, and then now we just have a fixed columns, but then we change the row. Yeah, you don't have to return anything because they just modify the array directly. So this is just of m plus n space. I think the runtime it's the same. Runtime's the same. Looks like the memory is kind of good as well. Let's see how we can do it to be a in place solution, like constant space solution. So let's reset this. Yeah. So let's just go to the theory first, right? So this is how you do it in like columns and rows. Let's see if I can clean this up and see how we can do it in a constant space. So one idea is that you have a marker, right? you have a marker where you see if there's like, oh, does it any zero in this row? Or is it any zero in this? But you don't create like a extra data structure. So one way you can do it is that you treat this first row and first column to save if you have something in your row or in your column is zero. So let's say in this case, right, we see that yeah, there's a zero here. So for this row, which is row 1, we said there's a zero here. So we update this to be 0. Right, so we let's use another color. Let's say I update this to be 0. And then for this column as well, right, I see, oh, there's a 0. So I make this to be 0. So later on when you when you zero out, you just go through the first row and first column and then see like, hey, it's at 0. And I see a 0 here at 1. I'm like, oh yeah, that tells me that, yeah, I have to zero out the here, right? I have to zero out here. I have to zero out here. But the question is, this will, your intention, it's you want to zero out the one in the middle, right? So this will be still 1 on the side. But one problem with this is, how do you know this 0 means this row instead of, maybe there's initially a 0 right here, so you might want to also zero out this entire column, right? So that is something we need to take care of, is because if you use the first column in the first row to be the marker, then we need something to store and to know whether we have 0 initially on the first column as first row. So what we can do is we can just initialize a variable, 2 variables instead. So one is like, does the first row has 0, and the first column has 0, right? First column has 0. Sorry, my handwriting on the mouse is kind of worse, but this means first column has 0. So if we find that, we just go through the first column in the beginning, right? Maybe this is not a good example, but let's look at this. This is 0 on the first column and first row. So if we found that there's a 0 in the first row, then we set it to be true, that we have a 0 on the first row, 0 index, right? So we just set this true. And then this is also in the first column, right? So we also set the column to be true. So later on when we said, oh, this is 0 right here, okay, yeah, we know that this is initially a 0 because we look at the flat and look at the variables and said it's true. So we zero out the first column and the first row. Sorry. So this is how you want to do this. And then later on you can treat your first column and first row as the marker row. So how exactly we're going to code this? Let's look at it together. So we will, at this starting, we do the same thing. So we initialize m and n. All right. So we can do something called first row has 0 to see if first row has 0, right? And then we set it to be false with 0 in the beginning. And we're not modifying the array with this, so it's okay if you put it 0 or 1. So we will go through all the column in first row. So if there are any 0 in the first row, then we set that, oh, okay, first row has 0, set it to be true, and then we can break this. And then I would like to do the same for column. So I change this to be first column, I change it to be I, range m, and then I first column, and then I set this to be 1. Right. So since we use the first row and the first column as a marker, so we start with index 1 instead of 0. So we can go through everything in the array right now. Yeah, as I said, I want to start with 1. So this is something you want to modify. And then if we set the matrix I0, I'm sorry, if the matrix ij is equals to 0, then we try to make the marker, which is the first row and the first column of that, to be equals to 0. Right. I think it's clear right here. So this is just the processing from every single point, but instead now we remove the first row and first column to go through, and then instead of adding it to the row and column set, we add it to change the marker. We change the marker of the thing. And if you see repeatedly having 0 in the first in the same column, it doesn't matter because you change thing to 0 and say there's a 0 in the column. So it doesn't matter. So after that, since we already set the thing to be 0, now we can use the marker. We can use whatever in there and change thing, right? So we can go through the first row first, and then we can set for j in range of n. So if we go into the first row, and then we set if matrix 0 row, and then for this different thing, it's equals to 0, then we know that the column that we're going to the first row. So we was finding 0 in the first row, and then we said when we find something, it means that that column is trying to 0 out. So if we found that, then we can go through each of the then we can go through each of the row of that column. So we can say for I in range m, and then we want to set the matrix at ij to be equals to 0. So we then can do the same thing for the column, right? So now we look at the column. So this is just in range m, sorry. So if matrix I at 0, which means we're looking at the first column and then going down different row, and if that is equals to 0, then we can go into that column, that row, and then change everything there. Right. And then now we can check the flat. Now we check the flat, right? So if first row has 0 indeed, then what we want to do is we want to go through everything in that row, in the first row. Oops. And then 0 out everything. 0 out everything in the first row. So we go down each of the column and then change that to be 0. Do it the same for the column. So if the first column is 0, means that go down the first row, everything need to be 0 out. So this will be I and then 0. So in this case, we 0 out everything. Oh, there's a wrong case right here. And I think because of here, I need to also start with 1, because yeah, just we need to check if that is 0 on the column in the row with the marker, so we don't want to actually modify the first one. So with this change, I think we're able to pass it. Yeah, so I don't know if this is better in memory in this case, but this is indeed of 1 because we're not making extra data structure. So yeah, the runtime is still the same of n by n, but this will go through maybe like 2 times. So yeah, either way you have to go through it to modify. So it just really depends on that. And yeah, therefore I think we have done the constant space solutions. So thanks for watching, and hopefully, yeah, there will be more to come.